Let's go through LeetCode 863, all nodes distance k in binary tree. For this question, it gives us a binary tree root and also a tree node target. And let's find all of the node which has a k distance to target, return a list of integer. And it says that all of the value in node dot value are unique. So intuitively, for this question is that we use a DFS create a map, right? The map will be for every node, it will goes to a list of node. So we need to convert this tree to a map of, for example, map of we can be integer or list of integer because they are unique or tree node, right? What you can do both way, right? This tree node. And this will be our map, right? Equals something. And when we do is the DFS root, for example, parent is none, and map. Do DFS to compose this map. After we have this graph, right? A map. Then we from target to BFS to find the result. So do you like this? The DFS has the ON time complexity, and also BFS has ON time complexity, but it also have a map as a linear space complexity, right? So it will be ON time complexity and ON space complexity. But if this question, there is some follow-up question is that can we use the constant uh, uh, space complexity and also still keep the ON time complexity? It is doable. So what we do is that we have several steps. Step one, right? Step one is from target to BFS, it's child trees, right? Or it's child children, right? And get all of the all of the nodes which have the get k distance, right? And add it to result. And step two is so this is the first step. We BFS, BFS find this. Just a BFS is a child, right? Step two, what we do is that we already get this, right? Then we remove this. Step two is remove target left, target left, target okay, right. So what does the remove mean, right? Remove is set this one as none, right? But this change the tree's structure. If we don't want to change the tree structure, we can use temp, right? Temp to store target dot left and target dot right, and then put this one as none, right? So the third step is that we need to we need to now what we need is that we need to from this path, right? From this path to uh, revert this path, right? So revert will be like this. So we create a new tree, and the root will be target. And we create a new tree like this, right? So we are going to revert the path from root to target. Well, we call this kind of path is critical path, critical path, right? So for this one, we're going to, there are some ways to do that. One is that we DFS first get the path, for example, left, right, and get this to get a target, right? And do the way like reverse the linked list uh, uh, to do this kind of path only. But it will be a bit complicated, a bit more code one, and not be elegant. So what we do is that we need to use DFS way, right? DFS way. Um, we are let's first finish the whole structure first, and then talk about the DFS way. How can we revert this kind of path? And then the fourth step is we have a new tree root is changed to target, right? Then we do EFS from targets, right? And to get a result, add a node and add a value to result, right? Of course, if we don't want to um, optional, right? Optional. We want to revert back this kind of tree structure. This will be optional file. Optional file is that we do DFS again from target to this kind of root to revert back. DFS to revert back, and also add temp one, temp two. So we here, right? So in step two, we use the temp to target left, right. So to revert this tree back. So this will be the whole concept. So how can we do the DFS way to revert this kind of critical path, right? So let's see, there is no this part already, right? So let's say if we have tree like this, 3, 9, 10, 11, 5, right? So it's already, and 6, 2, 7, 4 already been removed. And also we have 1, 0, 8 here, right? So what we do is that the DFS, we are going to return a value, Boolean, right? DFS, we have a return Boolean, means if this node is on the critical path. So what is a critical path? Is this path, right? From the root to target, we call it critical path. So the exit condition is this node equals target, right? So it will return true. And we find this. What we do is that for this DFS, we are going to have node previous and also when we do DFS, we need to find the target, right? Target. So the exit condition is this node is equals target, right? So what we do is we put 5 select as 11, right? So this will be its exit condition. And then actually for this step, we can also put 5 right to be 11. Both will be work, right? And and now let's this is the exit condition, right? And when we retrieve back, 11's right is 5, right? Because 11's right, this kind of path already been moved to its parents, so it's become empty. So we are safe to put 11's previous to its right. So we put 10 here, and also 10's left is is return true, right? So we are able to put the 10th left 9 here, right? And also ninth right can be so be true. So we have 3 here, right? So we recompose in this way because because we already placed the every node is a child, which if it is already on the critical path, for example, this right, we already put it as parents, so we are able to this spot will be empty, so we are able to put its previous to change the, for example, it 10 to here, right? So because we moved this one as empty, so I was able to put 10 to 11th right. So after this one, any nodes which is not on critical path, for example, we have 7 here. So you'll see this will not be affected. We have 7, right? So for example, you will have 11, right? So if it has left child, for example, 20, right? We can still have a 20 here. And also 3, right? This part, we just put all of that as its right child. And for example, if 9 have left, you'll see it still has space. Because what we put is previous is always this one's critical path we already revert, so we'll have empty spot. So so this will be the DFS part. And let's write code for this. So I'm going to have a list of integer result equals new array list. So let's say if k equals 0, right? Just the return, just so we have a result, add target value and return result. Okay. BFS part is easy. BFS part is easy from target and K result is just a BFS a tree, right? And what we need is we need to remove this one to be none, right? So we need to have, after we do BFS, we need to remove these 2 branches. So we have target dot left equals none, target dot right equals none, right? This is, if we want to implement optional file, right? So we can have, for example, pre-node temp1 equals target of the left, right? We need to put this one ahead of this. And pre-node dot temp2, right? And equals this one, and then set this as null. So this is optional if we have optional file, right? And then we do DFS. So DFS, we are going to have a node and it's a parent, right? It's a we call pre target. And after we do DFS, we already compose a new tree. The target will be the root. So we can call this BFS again. That will be target page result, right? So option 5 is we need to revert back this tree, right? We should DFS again, right? But DFS again, but now we are from target now to root, right? And optional 5 will also have target dot left, just temp 1, right? Doing like this. So, but for this option 5, I'm not write this code, but just need to know if we don't want to change the tree structure, we can have some code here. So let's write the BFS in the end, return result. So private void BFS. So tree node um, indicate list of integer results. So what we do is that we need a queue tree node queue equals new array deck and queue offer node we need to have intercept equals to 0, right? While queue is not empty. So what we do is that we need to have int size equals queue dot size. Then for int I equals to 0, I small in size, I plus plus int tree node current equals q dot 4, right? Then I will say if tab equals k, then we'll have result add current value. And we're going to say if current left time equal to none, then we're going to have q offer current left. And we'll say if current right time equal to none, q offer current right. And for this step, should increase and don't need to return anything. This is void, right? So this BFS is kind of simple. DFS, we need to have a Boolean return result. Means whether this kind of node is on the critical path, right? So we'll have tree node, and we'll have tree node tree, right? Or you can call parent tree node target. So there is exit condition. First thing is if node equals none, right? This one will just return false because it's we didn't find. And we'll say if node equals target, right? So we just have node dot. Actually, this one left or right both will work. Equals 3 and return true. And we'll say if DFS node dot left node target, right? If this is true, what we do is that node dot left equals pre and return true. And I will say if DFS node dot right node target, we'll have node dot right equals pre return true, right? Otherwise, we just return false. For those kind of false, those kind of it's not in critical path. The locations will not be changed. So this will be the DFS part. Okay. So this will be the solution without using map. If this list, for example, if this list already giving us, right? If this list already giving us, it will be no actual space, right? So if this one has one of the parameter, otherwise, we'll say this one may still be. So if the question changed for example, list of this, right? So that will be constant space. Python code. Python code is very similar. Result equals this, and if k equals 0, result append target dot value, return result. Then we're gonna have self dot BFS. I'm going to write BFS below target k result, and then we'll have target dot left equals none. Target dot right equals to none. And then we have self.dfs to revert root none. This parent is none and the target, right? After that, we already have a changed a new tree, which is the root will be target. So we just have self.bfs target. The result, run and return result. So we are going to define BFS self node tree node k int, and the result will be a list of int. Q equals deck and the Q append node that equals 0, while Q size equals length of Q for in range size. Current equals Q dot top left. If step equals K, then we're going to have result append current dot value. And then let's say if current dot left is not known, again Q alpha current dot left, and let's say if current dot right is not known, Q alpha current dot right. So of course, this for loop we should have a step should plus equal to 1. So this will be the BFS, and the DFS so we'll have self node should be so this one will be optional because it can be none, right? But BFS is not necessary to be not option because the target or root will always not be none, right? So this one we should be optional. Tree node 3 is also optional. Tree node and the target. This will be just tree node, right? Because it's giving us. So this one is going to return Boolean. So what we do is that if not a node return false, and also if node equals target. So what we do is that we're going to have node dot this will be left or right, both will work, because pre and return true, right? Because this is on the creative path. And let's say if self dot dfs node dot left and node target, then what we do is that we have node dot left equals 3, return true. And if self dot DFS node dot right node target, we're going to have node dot right equals 3, return true. And the last condition is return false. Append. This is append.